Good.
Hi everybody, and happy Wednesday. I want to do a special shout out to my nephew Mason, my nieces Layla and Bella, because I know you guys just started watching. Anyways, welcome to Lava Lamps 101. Today we're going to make lava lamps. And when we make them, there's two scientific processes or principles that we're actually using. So I want to go over those just briefly with you. We have polarity and we have density, okay? Those are really important words to note in order for our lava lamp to work properly. So I just want to give you a brief little explanation of it. Polarity, you guys, is when you have two objects. You have a positive, like a magnet, and you have another object, like a piece of metal with a negative charge to it, and they have an attraction. So polarity is all about attraction. Keep that in mind, okay? Now, the other thing we want to be kind of familiar with, which has to do with polarity, there are objects that have no polarity. They're nonpolar, such as two different metal pieces of metal. If I put them together, it doesn't matter what I do, they're not going to stick together. So we have polarity, where things stick together, and then we have non-polarity, where they don't stick together. Okay? Well, now, the other principle is density. Now you guys, granted, these are very complicated, but I just want to keep them simple for you so that you understand what's happening when we make the lava lamp. Density is when we have an object, a couple of objects, and it's the measure of how compact something is in a particular container. Now, if you thought that I had 32 pieces of cotton in here, you were correct. That is how many we have in here. If you thought I had 10 rocks in the same size bag, you were correct. But here's the difference. We have a piece of cotton and we have a rock. I can't squish this rock. That means it's dense. I have a piece of cotton. I can smash it. That means it's less dense. There's density there, but it's less dense. So density, again, is how much of an item can fit into a particular container. And that's really important to know when we're making our lava lamps. Okay, next, let's take a look at what we're gonna need to make our lava lamp. You can use any type of bottle that you want. It doesn't really matter with this. You can have glass, plastic, recycle them. We also are going to need vegetable oil. I want you to remember that vegetable oil is non-polar. No attraction. No attraction. We have water, however, which is very polar. It has a lot of attraction there. Molecules hold together. So that's important. We're going to be using watercolor or food coloring to give it some color. And we're going to also be using Alka-Seltzers as our motor to get it activated. So I have a measuring cup. You'll notice that I set things up again with kind of a draped towel and gloves, because when I did it at home, you do get food coloring on and it will stick to you. Okay? One other thing before we actually get started, I want you to keep in mind some questions. What's happening with the water? Do the water and the oil mix? And what is causing all the water to rise up? Okay? So I've got my measuring cup. I'm going to take the oil first. And what I'm going to do is I'm going to put in 1 cup. I'm going to show a point to you. I'm only going to add 1 cup of oil. Now, I'm going to add 1 cup of water. I'm doing this so you can see you can understand that the exact same amounts of the liquids are the same, but I want you to watch what happens with the 2 liquids. And these are a cool little thing to make. So watch that. Watch what's happening in here. Are the water and the oil mixing? Are they separating? Is the water on the top or the bottom? Why is that? Okay, so we have the beginning of our oil lamp, which is kind of groovy. You can get as fun with these as you want. I'm going to stick with yellow. I like yellow. So I'm going to add not a lot of food coloring, but a few drops. Again, watch what's happening with the food coloring droplets. 1, 2, 3, 4, 5. There we go. You can add other colors if you want, but what will end up happening is you will truly have another color here. I'm going to add some red. Notice what's happening with the food coloring droplets. Now we're going to get our engine started. We're going to take the Alka-Seltzer. Now at home I made the mistake and I put a big chunk in, and if it was a big bottle it probably wouldn't have exploded, but this is little. You put a big chunk in, you're going to get a big reaction. But watch what's going to happen. You're going to sprinkle it in there. You guys check this out. Look at what's going on there. If you get close, you're going to start to see, you see the fizzing going on the bubbles? Now watch as the water droplets start moving to the top. They're going to start moving. What is going on with those pieces? With the Alka-Seltzer? With the water? And you'll notice it's starting to get activated. You can start seeing those droplets of water going up and rising. Maybe I'll put some more food coloring in there. Motorized engine in there. You're getting that kind of reaction. What's causing the water to rise up? I'm going to do another one for you. And I want to show you just what can happen if you put more oil in. And this time I'm not even going to measure. I'm just going to put a good amount of water in. And I'm going to take some of that oil out of there. Okay. Now I'm going to add water. Again, it's polar. And I want you to watch what happens with the water. Add some more food coloring. I'll add a blue one. Some more tablets. We want to activate it. The smaller pieces might do a slow run, but if you look closely, you're starting to see the bubbling action, and that's how lava lamps look. You're seeing that reaction, okay? You're getting a little more of that lava reaction or look in this one because this one had more oil. I wanted to point this out with just the same amount of water and oil that it didn't matter. The water was still going to go to the bottom. But look at that. There you go. Those are your lava lamps. It's kind of cool looking, isn't it? Okay. And as we keep that going, you can make, like I said, you guys, you can use different size bottles. So let's look. I really like that one. That one turned out kind of cool. So let's look at what happened here, you guys. Again, looking at our principles. We have polarity, no polarity, and density. Well, I'm going to step over here because I want to point this out to you a little bit. Okay? Our water molecules are polar. That means they have a positive and a negative charge, and they need that for their structure. So if I take, again, I have a magnet, a positive, a negative, another positive, another negative, I'm starting to create a water molecule. Because this is what they've got to do to survive, to hold on. Because remember, water can be a solid, a liquid, and then a gas. So that's what's occurring here. And by doing that, look at that. They stay together, so that also makes them dense. That's why the water dropped to the bottom of the jar. Then we have oil. Why did the water and the oil not mix? Well, here's what happened, like you said. It's not polar. That water or that oil does not need to attach to it. It's balanced just like it is, okay? And so we, like we said, we talked about density. And I'm gonna step over here for a minute. Like we talked about, we have objects. I have 32 cotton balls in here, and I have 10 rocks. Now, just like I was showing you, that water was more dense. So it's going to drop to the bottom because it's not necessarily just heavier, it's actually denser. So, keeping that in mind, that's why the water went to the bottom, and that's why the water and the oil didn't mix. Now, let's look at what motorized our boat, or what motorized our lava lamp. Well, we put the Alka-Seltzer in here, okay? And when we did this, these little particles react with the water, and they create what we call a carbon dioxide gas bubble. And what do we know about gas? Well, I'm going to show you. Gas, take a balloon, our air is a form of gas. Gas rises, right? And when I let go of the item and it's going to take off, well, the gas is out, the item drops because it's dense, just like this. When the Alka-Seltzer and the water react and make the carbon dioxide bubbles, they rise, that gas rises with a little water droplet. When it gets to the top, I'm going to do this, I'm going to try to get the camera on it. And even when you do yours, you're going to see that the bubbles are rising up. And when they rise up, they're going to pop. And you can see them popping. Once they pop, that gas is released, and the water droplet, again, is now dense, so it's going to drop back down to the ground, to the bottom of the jar. And then it will repeat itself. The water droplet will attach to another carbon dioxide gas bubble, go up, pop, and then drop back down. And so there, you guys, is lava lamp making 101. I hope you had a great time today. I hope you make yours. If you do, go to the webpage, go to the comment section, and put some pictures on. Share your ideas. Tell us how yours turned out if you came up with any other creative ideas. So, had a good time. I hope I really enjoyed doing these. I hope you learned a little bit. I hope you learned that learning can be fun, making things can be about learning. And also check the webpage for our activity for next Wednesday. And we will be looking forward to seeing you at 1 o'clock. And until then, keep imagining your story. Have a great week.